Alright, greetings! So this is again for my CEC 112 class. What I want to do next is solve problem 2, so our second Python problem, which involves calculating roots using the quadratic equation. And so we're going to set up a logical block so that based on the discriminant, we're going to return 2, 1, or 0 roots. Okay, so cool. So the calculator is going to be set up. So we're going to display at the top when I run my program again, quadratic calculator. Then I'm going to ask for inputs of A, B, and C, and then I'll compute the discriminant. And based on the discriminant I calculate, we'll then tell the user how many roots there are, and then we'll display the roots. Okay. Cool. So let's do it. So I just recorded a video where I solved problem 1. So now we're going to solve problem 2. So I'm going to call this Python week 1 problem 2, right? And I'll try my best to remember to share the link to my solution as well, so that you have it right after the submission deadline, just in case. Okay. All right, and so let's take this piece by piece. Okay, and so I'm going to start by just displaying quadratic calculator. Okay. And so remember, to display quadratic calculator, all right, I'm going to use the print function. I'm going to print a screen. So print is going to take as an argument in double quotes the argument. I'm going to give it as a string to print to display. And so I'm going to print quadratic calculator. Okay, I'm going to save it. And I'm going to click run. It runs as I expect. Good. Okay. Next, I'm going to ask for input, right? And I'll try and go a little faster compared to the last one. I want the user to provide inputs of values of A, B, and C. Okay. So I'm going to assign to the value of A the result from asking the user for an input of A equals, right? So the prompt will be A equals. They're going to enter a number. I'm going to assign that to A. As we saw in the last video, when I just have the input function and the user specifies a value, Python's going to interpret that by default as a string. So if I want a number, a numerical value, a float being a number including decimal points, I need the float command to convert that to type float. Cool. Okay, so A is float, right, of that input specified by the user. Okay, then I'll do the same thing for B. And you know what I'm going to do? I'm going to copy and paste. Boom. Changing that to B. And then I'm going to do the same thing for C. Notice will pop up here in a second that I've got to go get my kids from school. Don't worry about it. I'm still good. Okay. So C, bam, got it. Save it. Okay. So remember, when I look at these statements, I'm covering up the equal sign to the left. So first I'm going to ask the user for input with the prompt, say A equals. User specifies a value that I'm converting to float, and then that's going to be assigned to the value, or to the variable A, right? So equal signs, right, are variable assignments. It's not some sort of mathematical equation. Okay. Cool. So now that I have A, B, and C, okay, next we're going to calculate the discriminant and print it to screen. Okay, so I'll do this part, display to screen, and then test. Okay, cool. So in terms of discriminant, I call it discrim. The discriminant is this term that I'm going to compute the square root of, b squared minus 4ac. Okay, and what's nice too is the variables I'm using, A, B, and C, are going to allow me to type up my code as using similar notation to this mathematical equation, which helps me keep track of things and make sure that my code's making sense. Okay, so my discriminant is going to be b squared. Remember, squared isn't a caret. Okay, it's going to be b star star squared minus 4 times A times C. Okay, and then I'm going to print to screen discriminant followed by that value, and I'll run that and make sure that I've got everything working correctly. Okay, now as I keep writing than running, it's going to take me longer to write the code, but the hope is that longer time that it takes, right, more than makes up for it, so that if I have a bug or a mistake that gets that enters into my code, it becomes easier to troubleshoot and find it. Okay. So hopefully it ends up as being a positive, right? That extra investment of time is worth it. So discriminant, okay, And so we have discriminant and then just, space, it's going to display it. Okay, so it's going to print to screen discriminant, and then I want to display what I have assigned to discrim. Okay, so cool, save it. I'm going to run it. Now for the values A, B, and C, I'll use 1, 2, and -5. 1, 2, and -5, and I get a discriminant of 24. Cool, right? It's working right. Okay. So what I'm going to do next is, I'm going to add in my logical block. Okay, and all I want to do in my logical block is, I'm lost for words. In my logical block, I just want to determine how many roots I'm going to have, right? And basically what we're looking at is, well, if my discriminant, this term is positive, okay, then I'm going to have 2 real roots, right? Because it's going to be plus or minus the square root of that positive number. If it's negative, then I'm not going to have any real roots, right? Because if it's negative, then I just get an imaginary number, right? That's no real roots. And if it's 0, well, square root of 0 is just 0, so it doesn't matter if it's plus or minus 0, it's the same. Okay. So I'm going to add that logical block. Now when I add that logical block, right, so just a note, right, is what I tend to do, me being anal, is I will check to see if it's positive, okay? I will add a logical check to see if it's negative. I won't have a check to see if it's 0, right? I won't check for equivalence. I'll just keep this in my, general case of else, just because I'm always worried about checking for equivalences of numbers involving floats, because sometimes interesting things happen with floats. Actually, I'm not sure. Let me see if I can get it. So if I do Python 3, so if I do like 2 minus 0.9, okay, that's not a problem, right? So sometimes there's some interesting behavior, and there were ones in the notes. So actually, if I fly over to our notes, which are on Canvas, and one of these guys, but anyways, so I'm just always anal about numerical comparisons. Like here, I get 2.8, and so that's as I expect. But there's cases where this isn't always the case. Okay, and in the moment here, I just can't happen to get any of those to work. Oh, so here's one. So if I do 2.1 minus 0.9, okay, instead of just getting 1.2, right, I get 1.2, and then I get 0, 0, 0, 0, 0, 0, 0. I get a bunch of zeros and 2, right? And so the thing is, if I were to check if, 2.1 minus 0. So if I do 2.1 minus 0.9, okay, and let's see, if I check to see if that's equivalent to 1.2, right, I actually get false. Okay, so 2.1 minus 0.9, if I check to see if it's equivalent to 2, right, it's false. And so even though it's 1.2, right, this is just numerical, sort of error that I'm seeing here. Okay, so I always err on the side of caution, and I don't check for, I try not to check for equivalences of floats. Okay, but that's okay. We can deal with it. Okay, and let me show you how we're going to deal with it. Okay, so now I'm going to add my logical block. Now your logical block, this is where that comment of formatting is going to matter in Python. Okay, and so I'm going to start with an if statement, right? And so it's going to be if, and in the first case, I'm going to see if my discriminant is greater than 0, right? If my discriminant is greater than 0, if it's positive, well then that's going to be, I'm going to print, and I'm going to print, what am I going to print? 2 solutions, right? 2 solutions, right? Print 2 solutions. Okay. Otherwise, okay, oh, I thought I should take care of the formatting, but I'm going to do a shift tab to untab. Okay. So now I'm going to use elif, right? Elif corresponds to else if. So if I'm on line 8, if discriminant's greater than 0, then it's going to execute what comes below that statement, that if statement that's indented. Okay. So if that's true, then it's going to perform what's on line 9. Okay. If that's not true, it'll then and only then proceed to my else if statement, which is on line 10. So if line 8, if that's true, okay, it evaluates line 9, then goes to the end of the block. Okay. But if line 8, if that's false, then it's going to go to line 10, which is going to be my else if statement. And here I'll check to see if my discriminant is less than 0. Okay, so if it's less than 0, well, the square root of that would give me an imaginary number. So I'm going to print. Okay, and what do they want me to print? No real solutions. And so I'm going to print no real solutions. Okay, and actually let me deviate, up here. So 2 solutions. So I'm going to call it 2 real solutions. And now this case, right? So I press return, then untabbed, is rather than checking to see if it's equivalent to 0, at which point I'd have 1 real solution, I'm going to count for this using an else statement. Okay, and so else is all other cases. So as I proceed, if line 8 is true, it'll perform the calculation on line 9 and then go to the end of the block. Okay, but if I'm on line 8 and that's false, okay, then we're going to go to line 10. If line 10 is true, it evaluates line 11 and proceeds to the end of the block. Now if I go to the beginning, if 8 is false, it proceeds to 10. If 10 is false, then it proceeds to 12, and then it's going to execute, right? So it's an else, so it's it's going to be if I get to here, then I'm going to execute what comes below on line 13. Okay, and so in this case, then it must be that I have 1 real solution. Okay, cool. All right, and so let's test this out. So I'm going to run it, and so if I start with 1, 2, and -5, 2 real solutions, that's good. Okay, now if it's 0, so it would be 0. So checking to see if I get to the end. So if B is 2, that's 4. And so if A and C are both 1, that'd be 0. Okay, so let's try this. So I'm going to try A of 1, B of 2, and C of 1. I get a discriminant of 0, so I get the 1 real solution case. Perfect. Now let's see if we can get the negative. And so I just need B squared to be less than 4AC. So let's try if A is just 5, B is 1, and C is 7. Right, so I get a discriminant that's big negative number, no real solutions. Yeah, it works. Okay, cool. Okay. And again, I'm just not checking for equivalence to 0. All right, and here I got a case to work. Right, 2.1 minus 0.9. It's 1.2.0000002. Right, it gets some numerical business going on. So even though 2.1 minus 0.9, right, that should evaluate to 1.2. If I were to check to see if it's equivalent to 1.2, right, it's actually false. Or if I try one of these other examples, so if I did 2 minus 0.9 and checking to see if that's equivalent to 1.1, right, which is this top case, right, 2.2 minus 0.9 actually got 1.1. Okay. All right, so that one, right, it works out as true, but like the one above it, which should be false or also true, it's false, right? It's madness, right? And so my analness is just, these are cases where if I were to check equivalence and have a case like this come up in my code would still work, right? It wouldn't display an error message. And those are always the worst errors to have. It's the worst error that you can have is an error where your code runs and doesn't complain. Because then you're going to be much more less likely to go try and troubleshoot or acknowledge that there's an error or an issue. Okay, so this is me, in my experience, getting burned and trying not to get burned again. But I digress. Okay, so all right, so now let's actually calculate it. So similar to the last video, we're going to need a square root. Okay, so we're going to need the square root of the discriminant. And so to calculate the square root of the discriminant, I could either load the math package and then use the math.square-root function, or I could take the discriminant and raise it to power of 0.5. Okay, what you do is up to you. Okay, and I'm just going to import the math package just because. So I'm going to import math. All right, in the last video, we discovered it wants us to have a space right between the two of them. Okay, cool. And so then if I have 2 real solutions, so I'm going to start by discriminant, and I'm going to compute the square root. And so I'm going to first calculate math.square-root. I'm going to compute the square root of this discriminant. Okay, and so then solution 1 is going to be negative b plus this, variable that I just stored the square root of the discriminant to, divided by 2a, 2 times a, 2 times a, and then solution 2, I'm going to copy and paste. Solution 2, it's going to be negative b minus the square root of the discriminant. And then I'm going to need to print them, and so I'm going to print. Okay, and the first one I'm going to print is sol1. Okay, and then the next line I'm going to print sol2. Bam. Okay. And this is cool, right? So you see in this if statement, it actually draws a line showing you what's included in this first if statement, right? And I could close it and expand, which is kind of cool if you have a long code. Okay, making it clear exactly what's included in there. And this is where the comment in the notes that formatting is important. Well, the formatting, the white space is important here for defining what's included within your logical block. All right, so else if no solution, so I don't need to do anything, and then else if there's one real solution. Okay, I got this. Well, then I don't actually need the square root of the discriminant. The square root of the derivative, the square root of the discriminant is just 0. And so I have just, my one solution is just going to be negative b divided by 2 times a. And I will print that to screen. Okay, and that's it. So if I save it and I run it, ba-bam. Okay, start with the example given, 1, 2, negative 5, 1, 2, negative 5. Bam, 2 real solutions, and I get exactly their answer. Okay, so cool, right? So there's my code, right? As it's working, here I use the math function to get the square root. You could also just use star star 0.5 to evaluate the square root as well without needing the math function. Okay, hope that helps. I'll try and get this posted and share with you a link to my code as well. But let me know if you have any questions. We'll see you tomorrow in class.